Hey guys, welcome back to AI with MJ. As I was solving NeetCode 250 questions, this is gonna be problem number 6 from that list. I'm gonna be pasting the question. I found a couple of variants and like some tricky edge cases, and I will go over it. I will do it within 20 minutes. All right, I'm pasting the question. Let me set the timer. Okay, so the question is, given an array of strings, group the anagrams together. You can return the answer in any order. Oh, I forgot to paste the output. Okay, so here we see that A, B, C, C, A, B, B, A, C are all anagrams because they contain the same letters in each word. Got it. And I just have to return a list of words. A few questions I would ask. Mm, input only alphabets. Also, string length, like the input length, and length of each string inside the inside a strings. So for this one, you can only consider lowercase English characters, and string length would be around 10 to the power of 4. So like it could have 10 to the power of 4 strings inside, and length of each string could be just from it could be till like 1,000. Also, one more question. Can a string be empty? Yeah. So if it is an empty string, then that will be just a list inside. And what to do with like multiple empty strings? Like every time there is an empty string, we can just group them together. Okay. Um, One way that comes to mind is if we are here, we could have a hash map and sorted string, and the value would be the list of sorted strings, like the actual string. So if it is listen, silence, and list. But then this would be in alphabetical sort for each string. So, for example, we sort listen, and then it would be like E first, then I, and so on. And then every time we are here, we will append it. Like this is the key, the sorted version is the key of the string. Then we sort here, and then we see that this already exists, so we'll append it to the list of that key, and so on, and we'll continue till the end of it. Here, the time complexity would be O of n, because that is the length of the string, times k, which is the length of the string inside the string, into log of k for sorting. So that would be it, and space complexity would be O of n, as this is the resulting array, which would contain all the strings. And on optimization, I think could be done here. So instead of sorting this string, what we could do is we could have this hash map, but we could have like a tuple of values. For example, like we can have a tuple of 26 characters, so till 26, and this would be where, for example, this would become a unique key because if, like, let's say this is A, so we get the ASCII value for A here, and that would, and subtract it. So this here would become 1, then B would become 1 in case of A, B, C, and C would be 1, and rest of it would be 0. And then this is the tuple that we are at. This is like the key that becomes, and here we will append A, B, C as the string. And then when it comes to cab, it'll go and like again add 1 1 1 and check that this tuple already exists. So let's like just add here cab and move on until the end of the list. We are using tuple because we don't need to modify, and also for the list, it would not, like, you cannot have a list as the value inside the dictionary, like as the list as the key in the dictionary. Not possible, hence we are using that. And here the time complexity would be O of n in times k, which is n is like the whole length of the string, while k is length of each string because we are reprocessing that into a tuple. And space-wise, it should be O of k, O of n. So let's go ahead and code this one up. We can just say class anagram, and we can do define group anagrams. Here we'll just provide self, and we'll also provide strings, which is a list of strings. And our output would be list of strings. Yeah. And here let's do like a hash map, which would be, we can just do a default dict to avoid like any missing keys. So we could just get over it. Actually from collections import default dict, default dict, and here inside the, it would be a list of values, right? So that there's that. At the end we'll be returning list of values, so val for val in hash map dot values. That is what we're going to be returning. And now we'll go over every word in the strings. And as I mentioned, that we're going to have like a tuple, like the, so we add the word, so hash map would be our tuple of, we can call it like word ord dot append, and we append the word. this would append it if even like it there is no key. If there is a key, that would just automatically get appended. And here we can have like a word order, which would be equal to a list initially first, because tuples won't be manipulated initially. So we multiplied by 26 because there are 26 alphabets in the English dictionary. And then we do for character in word. And then at that each character in the word, we'll do plus equals 1. But here we cannot just like access the character. So we'll have to get the ask, we have to add it at the ASCII value. So old is the function that would give the old for that character. For example, if it's 97, I think for A, then it would be 97 minus 97, and that would make it like at index 0 is where there would be an increase in edit, like plus equals 1. And um, for example, if the character equals B, then this would be like order of character would be 98 and minus order of A, which is 97. So when we have like a 0 to 0 to 0, like 26 zeros here. So when at index 1, it will go ahead and increase the value. So this is what this line would do. And yeah, I think that is all. Let me just do a quick dry run. I'll do it like with only the initial ABC sample instead of going over the whole um, solution. So dry run. Let's say our input is ABC and CAB. So our hash map would be empty initially, and we'll go over for word in. So word here right now would be ABC, and our word ord for this would be again 0 0 0 till 26 zeros are met. And then we'll get word, okay, and then character for this is A. This word is equal to A. So we'll get the value again, as I mentioned, so 97 minus 97. So at this index, will become 1. Now the character is B. So this index would become 1. So it would be 98 minus 97 because that's what we're doing. And then when the character is C, we come here and we get this. And what we're going to do is we have processed all the characters. So we'll come out and this will be reinitialized. But before that, this line executes and we convert this into a tuple and add it as the key. So whatever this value was would be added as a key in the hash map, along with the word would be appended, which would be ABC. Then when we come to CAB, again, this is the word. Right now, we are still, this loop is not exited. So the cab here would give us the same result, like it will go from C, A, B, and we'll still get the same double. And then when we come to this line, we see that the key already exists, so we'll append the word cab here. And that's when we come out of the loop because we have processed all the words and then we return the value. We just return like values, like these values from the hash map, and then we return it in a list of strings as it was needed in the output. So that is the solution for this. There are a few, usually this is a follow-up question to valid anagram, like just a single string. But if suppose there could be one variation where the inputs are no longer limited to a lowercase English character. So how would you go about solving this one? So if this is the case, then what we can do is this frequency count like of 26 would not work. 26 frequency would not work. Um, so we could do like a different I think data structure. We can do like a hash map. So the key would become the character. Key would be the character, and that would be mapped to the word in the dictionary. For example, like let's say if it's 123, so this would be the key itself, and then 123 would be just the word that would be appended. Um, yeah, and like I don't think, and then we can just convert it back to tuple or a unique string. And also, since it's the same character, it would not be like repeated again. Yeah. And another variation I found was it's a more tricky question, but if it says that what if the input array of the string is extremely large and arrives as a data structure, as a data stream, sorry, can you group the anagrams without sorting all the string in memory at once? So just to test the understanding of like the limitation of this algorithm, um, so if it is a true streaming solution that is like processing the data without access to the full history, then it is like impossible for the problem, right? Like you need to see all the strings to know if they are like if they form a proper anagram. So the best way to answer would be like the true streaming solution is not feasible. We must store like the in we must store and index the group of anagrams as they arrive. And the most memory efficient approach would be a hybrid model where we can process strings as they come in and build a hash map in memory, which would again be like this solution itself. And it would just be like anytime a new word is added, we create it in the hash map. So yeah, I think I did it in 20 minutes. Thanks for watching.